Okay, so hello everybody, welcome to this video. This is going to be a video on cloud architecture. So we're going to be having an introduction. So as you can see, it's a nice beautiful day in England. It's nice and sunny, so I'm really excited about this video. So let's get straight into the content. So what we're going to be covering, well, this is a two-part lesson, right? So this is going to be an introduction, and the next video will be having more of a deep dive into cloud architecture. But so this is intended to be more of an introduction. But what actually we're covering? Well, let's firstly have a look at what the CCNA blueprint talks about in relation to cloud architecture. So there's a few things to cloud architecture. So in network fundamentals, in the blueprint, you have 1.1, explain the role and function of network components. 1.1g servers. Okay, then 1.2 describe the characteristics of network topology architectures. 1.2f on premises and cloud. So we'll be discussing both in this video and in the next video. And then 1.12 explain virtualization fundamentals, so server virtualization, containers, and virtual routing and forwarding instances. So VRFs, so virtual routing and forwarding. That's something also we'll be covering. That'll be more in the next video, but we'll be hitting all these topics in this two-part series. So I'm just going to check that this is actually recording, because I recorded this keynote before, right? And it didn't record, so it's the recording. Okay, that's great. So what is the breakdown of this lesson? And this, by the way, is for both lessons. So in this video, we'll be just having a look at these two. But then in the next lesson, we'll be having a look at the rest as well. So in this lesson, server virtualization, very important, private and public cloud. And then we'll be having a look at the three cloud models. We have infrastructure as a service, platform as a service, and software as a service. Then virtual router and forwarding instances, VRF, enterprise WAN connection to public cloud, cloud management, and then final takeaways, which is having a look at some of the most important things that we've learned about, and just trying to comprise them in a slide or two, so that before the lesson closes, we have a clear idea of the key points of the lesson, and then finally a quiz. So yeah, there's a lot to cover in this two video series. So I'm going to be bringing an analogy in, and this is our Buckingham Vales Grammar School, which you might be familiar with because I used this in my last lesson, and that was I think it helps to understand any concept through an analogy. So we'll be using Buckingham Vales School again, and I'm going to introduce you to two characters in this fictional school. So we have Stephanie, so our server engineer, and Barbara is our virtualization engineer. So I'll mention these two people, so just so you know, Stephanie is a server engineer, Barbara is a virtualization engineer. So let's get into the next slide. So what exactly is cloud computing? Now, I'm sure that everyone watching this video has used some sort of cloud computing service. So that might be, for example, Dropbox, because Dropbox, right, is it's a great platform for backing up your photos on your phone. So if you have to lose your phone, you still have your photos because they're in the cloud, right? In the cloud. But obviously that doesn't mean literally the cloud. Cloud is more of a metaphorical term to mean a remote location where your data is being stored, and there's some key things when it comes to cloud computing that define the service. And how exactly do we find it? Well, there's an organization called the National Institute of Standards and Technology. The National Institute of Standards and Technology. Now, this is a United States organization, and they have defined cloud computing, which is like this. So this is some key points from their definition. So firstly, by the way, there are five characteristics, right? Okay, and I refer to them as the NIST list. Okay, so firstly, widespread access, right? So widespread access. The cloud service needs to be accessible from different devices. Okay, you can imagine an organization. We're not just using Windows. We can be using Mac OS, right? So Mac OS, Windows, and Linux. Okay, and also we can be using not just Mac OS, Windows, Linux, but also we're using them from different devices. So you've got tablets, okay, like iPads, okay, or just tablets in general, okay, and could be PCs, laptops, so different types of devices. So our cloud services should be accessible from different devices. It shouldn't just be a case where it's only accessible from, for example, a certain fleet of devices. For example, only accessible from Mac OS. You can only access the cloud from Mac OS. If you have a Windows PC, you can't access cloud service. It shouldn't be like that. It shouldn't be the case that you can only access the cloud services from PCs and laptops. You know, we're in a world where services, we expect services to be, just in general, banking or any sort of service, music or streaming services. We expect them to be accessed from mobiles, from tablets, as well as PCs and laptops, because that we're in basically a post PC era now, where there's several types of devices being used. So similarly, cloud services should be accessible from different devices, different operating systems, and different form factors. So PCs, laptops, tablets, mobile phones as well. I didn't mention that. Mobiles. So that's all important. So okay, the service should be accessible from different WAN technologies as well. So the school uses a private WAN, so they should be able to access the cloud service from the private WAN. That's important. Now, resource pooling. So cloud service providers create a pool of resources, and they can be dynamically allocated for customers, okay, such as a school, but others as well. They could have, a cloud service. For example, if we have a cloud service provider and they're supporting Buckingham Vale School, they could also be supporting 20 other schools. They could be supporting many types of businesses in the area, in the country. So they have a pool of resources. They'll have a data center or data centers, and they have racks and racks of servers. And in those servers, they have virtual machines and containers, and those are being dynamically allocated to customers. Okay, and cloud service has the ability to handle dynamic workloads very swiftly, okay, and more swiftly than an on-prem deployment would be. So, for example, Buckingham Vale has a sudden increase in pupil headcount. They have 20 new students, and they need to facilitate 20 new virtual machines on the fly. Cloud service will be able to handle such workload. On-prem deployment might struggle a bit, because normally an IT department, you can expect an IT department to have more constraints and limitations on the resources compared to a cloud service provider. Because a cloud service provider specializes in providing these kind of services. An IT department has many responsibilities, and they can be other limitations as well with an on-prem deployment. So cloud is very efficient, and that's great about it. And so resource pooling is another characteristic of cloud computing services. Now, on-demand self-service, right? So Buckingham Vale's IT department choose when to start and stop the services without direct interaction with the cloud provider. So Stephanie, who was our server administrator, a server engineer at Buckingham Vale, she doesn't need to call or email Amazon Web Services, cloud services department every time that she needs to add more VMs. Like, for example, there's an increase of pupil headcount. She doesn't need to ring up AWS to add more VMs or containers to their service subscription. Well, to Buckingham Vale services, no, because they have on-demand self-service. So they have the ability, and I'll talk about this as well in a later slide, but basically there's something called a self-service catalog. So let me write that a bit more clearer. Self-service catalog, and that enables IT personnel to be able to request their own services without interaction without direct interaction with the cloud service provider. So without having to go through a support team, sitting in in an office at Amazon Web Services, or emailing their support teams. It makes the process much more efficient. And what's the fourth characteristic, right? So rapid elasticity. So the services need to be elastic, meaning that the school can quickly expand or decrease the resources of the services that as per the demand. So they can scale up and scale. They should be able to scale up and scale out. Scale up and scale out with their services as per demand, because obviously demand can fluctuate. It can fluctuate, go up and down, up and down. So likewise, the services, we need to be able to increase and decrease our processor memory storage as and when required. And finally, measured service, meaning the cloud service provider provides billing reports, and reports for billing, which also help with transparency as well. So being transparent with how the service is, basically what the cloud provider is seeing in terms of storage and usage of cloud resources, and it gives that usage measuring helps in both ways, billing and transparency. So those are 5 things, right? Well, I want to ask you now, how can you remember this list easy? Because there's 5 things there, but how can we tie these together so we remember them easier? You might have a method that you might be flashcards, might be it might be an acronym, it might be something else, but I've got something which I think might help. Now I'm going to give you this word, apidemia. Now that word doesn't really mean anything to nearly anyone. I googled it, and it's actually the name of a Spanish jewelry brand. But other than that, I couldn't really find any other use of that word. So it's quite a made-up word, at least in the English language anyway. But this word is, I've created it to help you guys remember, not only to help yourselves, help me and yourselves remember this list of things. So apidemia basically stands for access, pooling, on-demand, elasticity, and measured. And IA is just to make the word sound, it's just basically to make the word sound a bit better and a bit fancier. But apidemia, the focus is on these 6 letters here. Don't worry about the IA. Access means is referring to the widespread network access that we spoke about. Pooling is referring to resource pooling. On-demand self-service. So on-demand is taken from on-demand self-service. Elasticity from rapid elasticity, and measured from measured service. So hopefully that just helps you guys remember this a bit more easier. So hopefully that helps you guys remember those 5 characteristics of cloud computing services in a more easy way, and hopefully give yourselves a bit of an easier time. So let's go into the next slide. We're going to be talking about UCS now. Now, UCS, what does that actually stand for? It stands for Unified Computing Systems. Okay, it was released in about 2009, 2010. So it's been around for a while, but basically when this happened, this was quite historic, because Unified Computing Systems, right, it was Cisco's entry into the server market, and it was a big thing because they were producing now technology that was going to be used for data centers, but they were they were trying to unify several elements together, and it was it was quite a big thing for Cisco to do, to come, because obviously we typically think of them as a networking company, but now they were providing data center hardware and software that combines servers, networking, and storage into a single system that would be managed but from a GUI. So, integration of or combining try that again combining servers, networking, and storage into a single system that would manage through a GUI. Now, there's different tiers of there's different series of UCS. So we've got X series, right? There's X series. It's just good to know. We won't be looking at too much depth in this video, but I'll just mention we've got X series, B series, C series, and S series. Now, let's have a look at this diagram here. So this is just an illustration of what UC data center might look like, just to give yourselves an idea. So these guys here are fiber interconnects, and they're essentially the brains, and they host the user interface that we're going to interact with. They provide interconnection, because the fabric, which is the local area network and storage attached network traffic in the data center, that fabric, right, that traffic is feeding into those interconnects, okay? So feeding into these guys, the fiber interconnects, okay? So it's that's important to know. So those are the fiber interconnects, and very, very important what those guys are doing. And the FE stands for fabric extender. These guys are fabric extenders, and they extend the connectivity of the fabric internet connect, allowing for more servers and connections with a chassis. So the fabric extenders and fabric interconnects. Now let's move on from UCS, which is just a brief look at it. Let's look at servers. Let's look at server virtualization now. Still recording. Sorry, I recorded this earlier and it didn't record, and so I was very frustrated, so I'm just making sure it's still recording. Servers before and servers after virtualization. Well, this is how servers look before. So you can see it's quite simple. We've got server resources here, operating system. So, that could be Mac OS, could be Windows, could be Linux. Okay, if we're running a desktop software. Okay, but more likely we're going to be actually running Windows Server or a Linux server. A Linux. Okay, so either way, even if you run a desktop software, the concept is you've got the resources here, the server resources. There's your operating system, and your application is running on top. Okay, regardless of desktop or server software, most likely you run server software, but that's how it was. The problem was that sometimes we don't need to we don't need to leverage all of these resources for the applications. We don't need to leverage, they don't need the total capacity of these. So there's inefficiency. And what virtualization did was, what happened was we introduced a hypervisor, and the hypervisor manages the OSs run on top of this hypervisor. Okay, and now what happens is, instead of running one server operating system or even desktop operating system, we're running 4 operating systems here now. So we have 2 instances of Windows, and then 1 instance of Mac OS, and then 1 instance of Linux. So we have 4 virtual computers now running on a physical computer, and that enables us to get the most out of the storage, CPU, RAM, and network. And look, now we're running 12 applications, 12 apps on that same machine rather than 4 apps here. So we're getting 3 times more, in a sense, 3 times more productivity out of this same physical machine. Now, let's look at some commonly deployed virtualization vendors and products. So Microsoft Hyper-V, this is very, very common. Microsoft's virtualization solution. Then you have VMware vCenter, Citrix Hypervisor, formerly XEN Server, Oracle VirtualBox, and Red Hat kernel-based virtual machine, KVM. So those are 5 of the commonly deployed virtualization products. Now, let's have a look at what a container is. Now, a container, right? A container is... What exactly is a container? Well, Docker, who are one of the pioneers in this technology, define it as a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another. So it's okay. So if you have a container image, that's all the software that you need to run an application except for the operating system. Okay, the container is a standard unit of software. It's packaged up with your code and the dependencies, so the applications run quickly and reliably from one computing environment to another. Now, what to remember about containers is usually smaller than a virtual machine, measured in megabytes rather than gigabytes. But the container does not include the OS. You've got to remember that. The container does not include the OS. The server hardware will host the operating system, and a container engine is used to manage the containers. So, but the container, okay, does not include the operating system. Now, let's have a look at the physical data center network. So, in this diagram, what we've got here is we've got 4 racks of servers, right? So 1, 2, 3, and 4. We've got servers, and here we've got top rack switches. Now, these switches, right, are access switches, and they connect to these guys, the end of rack switches, which are distribution switches. Now, every data center will look like this, but this is just an example. It gives yourselves an idea that these servers, which are like our end devices here, they're connecting into the access switches. The access switches, okay, which sits at the top of the switch racks, at the top of the racks, and they connect to the end of rack switches. That's a typical design. That's one of the designs. Okay, traditional design. So let's talk about cloud computing services, right? So remember how earlier I was saying, well, cloud computing services need to have on-demand self-service. Well, this is what we're going to talk about now, because this was a traditional workflow for requesting, for example, a virtual machine. You have a person here in an organization. Let's call him James. Now, James is requesting a service. He wants a virtual machine being set up. Now, he gets in touch with Barbara, virtualization engineer. She interacts with the virtualization software. The virtualization software, for example, let's say they're using VMware, and this is APIs and the GUI. The APIs in Barbara's case interact with the data center. The virtual machine is set up in one of the servers. Lo and behold, James now has a VM. However, this process could be much more efficient. We wouldn't need Stephanie and Barbara to do this legwork here, because when you have a basic private cloud workflow employing a cloud services catalog like here, what we have is now, instead of Stephanie and Barbara getting involved, James can now interact with the catalog, request his VM. The API will interact with the API in the virtualization software. Interaction with the data center creates the VM. and James has a VM, but there was no need to get Stephanie and Barbara involved here. There was no need for that IT personnel, that the server and virtualization engineers to get involved. The cloud services catalog streamlines the workflow. It cuts out some administration and makes the process more simpler. Okay, the cloud services catalog, it has APIs to the virtualization software, and that enables the VM management from a user interface, a graphical user interface. So that is a private cloud workflow. Now let's I just want to break down these two terms, right? Private cloud and on-premise or on-premise cloud. Okay, now what's the difference between these terms? Well, private cloud means ownership of a cloud infrastructure by an organization using a service. On-premise, when that term is used in the context of cloud, or on-premise cloud, means cloud infrastructure is located on a site that's controlled by the organization themselves. So, for example, we have if we have Buckinghamville School here, and they have a DC which they manage themselves, okay, and they're hosting a cloud here. Well, that would be an example of on-premise cloud, because they own that building. This is their building, and they have a data center there that's controlled by them. That's an on-premise cloud. Private cloud just simply means you have ownership of cloud infrastructure. So you still have, okay, you have a private cloud. Put a little padlock here to represent private cloud. Okay, that's a private cloud, but the organization, the DC that's running it, is not owned. Okay, that is not owned by them. Okay, so this is kind of locked. Okay, so that data center is not theirs, but they have cloud infrastructure in that data center. Okay, the data center is not theirs. They have ownership of the infrastructure itself, but the actual building is not theirs. The site is not theirs. So while the servers may belong to them, they don't actually have ownership of the building. Here at Buckinghamville, they have ownership of the building and everything and all the servers that are running inside. So that is essentially the difference there. So looked at on-premise and on-premise cloud and private cloud. Now this brings me to the end of the video, so thank you so much for watching. Really appreciate everyone who watches my videos. Please stay tuned, please continue to follow the channel, and we'll be having more content coming out soon. Obviously there's a part 2 to this video that needs to come out, so please stay tuned for that. That'll be coming out very soon this week. So thank you so much for watching, guys, and take care everyone, and I'll see you in the next video. Thank you. Goodbye.